Hello everyone and welcome to my channel. I'm Dodgy Mango and today I'll be teaching you vectors. So here's a brief overview of all the things that I'll be covering in this video. So I'll be talking about the introduction to vectors, I'll be highlighting the difference between scalars and vectors, I'll introduce you to vector notation and also help you find magnitude of a vector. So before we start understanding vectors, let's think about the physical quantities that we encounter on a regular basis. So we use physical quantities like temperature, acceleration, speed, velocity and energy to better describe the world around us. Be it rockets, be it satellites, be it theme park rides, we can better describe them using vectors. But terms like speed and velocity can be used interchangeably. However, they have strict scientific definition, and that speed is a scalar quantity and velocity is a vector quantity. And to give you a head start, vectors give much more information than scalars. That is, to describe the directionality. So, you might be confused at this point as to what these quantities are, things like scalars and vectors. But scalar quantities have size or magnitude only. So if you talk about speed, say for example a ball was travelling at 3 meters per second, you do not know which direction the ball is travelling in. All you know that the ball is travelling at 3 meters per second. But to give the direction in which a ball is travelling, we can say that the velocity of a ball is plus 3 meters per second. Or it could also be minus 3 meters per second. What's up with the negatives and positives? What that essentially means is that I would describe right to be positive and left to be negative. So if I say my ball is traveling to the right, you know that it's traveling in the positive direction at positive 3 meters per second. However, if I was to say that my ball is traveling to the left, it would be traveling in the negative direction. So here's a handy diagram which would help us understand the links between all these quantities. So physical quantities can be split into scalars and vectors have also got a directionality element, and that they can be positive or negative. And you can change them. You can call left to be positive and right to be negative, and that's equally valid, which means then traveling to the left would become positive. Okay? So, to describe vectors, we use vector notation. It's like a little name you give to your vectors. So you can underline your vectors or you can make them bold. In printed text, it's often written in bold, but you know how hard it is to draw stuff in bold or write stuff in bold, so the best thing to do is to underline them. So scalars do not have underline underneath them, but vectors have underlines underneath them. Column vector notation tells you the quantity of a vector. So the alphabetical form or the algebraic form tells you the name of a vector, the column vector tells you the quantity of the size. So if you talk about a vector 3 and 4, what you do is go 3 to the right and 4 up. And you can say that is given by vector B. So vector B can be reached by going 3 to the right and 4 up. Okay, and here's a handy little notation or memory aid which will help us remember this. So x going to the right is positive and y going up is positive. So if I was to say that I want to draw minus 3 minus 2, that would be 3 to the left and 2 going down. So a vector can be reached there. Let's call it vector A. It's up to you what you call them. But now remember that vector minus A would be opposite in direction, and that would be 3, 2. So don't worry about this at this point. We'll cover a few examples which will help you better understand these vectors. Okay? So now, finding the magnitude of vectors. Vectors have directions, but when you find the magnitude of the vector, that's just getting to the scalar form, isn't it? It's basically used stripping them of their signs, their positive or negative signs. So can you see there's no underline here? There is underline here, but then the modulus sign, so the two vertical lines tell you that you are finding the magnitude of the vector. It's not very difficult because all you have to do is use the Pythagoras theorem to work out what the size of the vector is. So, just to remind ourselves, what Pythagoras' theorem is hypotenuse squared equals side 1 squared plus side 2 squared. And now let's use this to solve this question. So we've got a vector, 3 x component and 5 y component. So that's 3 along and 5 up. So now if you want to find the magnitude of this vector, what we would do is b with the modulus sign equals 3 squared plus 5 squared, which kind of got covered by ink, but let's write it again here. It's 3 squared plus 5 squared, and that gives you root 34. You can further simplify this, but you know it's going to be 5 point something.